No, that's not what I want. That's not what I want. That one. That's good. Let's make sure it's actually recording first. Yes. Cool. All right. So, programming fundamentals. That is what we are signed up to. This presentation is just giving you an overview, as I said, about the subject, what we're doing this semester, and for the next 2 years if you stick with programming. For the people in Year 12, unfortunately, you're only stuck with us for a year, but, you know, we'll see what happens. But this is what the goal is, what the end goal is, and I want to give you an idea of where we're going and why we're learning certain things. I get bored when I make PowerPoint presentations, so I put in silly pictures. They may not be funny to you, but as I said, I get bored, and so I put silly pictures in. So they amuse me. Hopefully they amuse you as well. This one's about an unpopular teacher, so I thought it was appropriate to start with that one.
You say you're unpopular?
Well, I can't say that. I'm not the one that's, you know, I'm very popular, according to me, but, you know, you guys are the ones that will judge that one. So anyway, all right, first of all, these are my contact details. If you need to contact me at any point throughout the semester or the 2 years. That is my work email address. I may have another email address soon. I'm going to create accounts for you guys I'll talk about that in a minute. But yeah, but that's a good email address. Also, if you forget this, on my staff room door, which is down the hall, the big fishbowl, you walk through it to get into this pavilion. There's my timetable up there and my contact details, which is pretty much the same one as that. The email address might be wrong as well. So, yeah.
Wait, it's 2014. Yeah, you used that joke already.
Oh, man! That's shock. In my defense, I wrote this last year. But that's not so much of a good defense. So, yeah, good point. No one in the other class mentioned that one. They didn't say that, oh, look, you was wrong. So, you're on my list because you pointed out my first mistake. You're on my list for the rest of the semester.
Bad list or good list? It's a bad list.
Well, it's a bad list, and I'm just trying to remember who you are.
My name's Cameron.
No, you're not.
Which one?
You.
That one.
I'm going to get it. No, I'm not. I also don't want me to record me guessing names because it could be a problem. Anyway, you're on my list. Alright, so anyway, remember, recording. All these tutorials, all these videos I make, I'm going to put them up, not only the video of me recording it, but also the presentation files themselves. I'll put them up there so you don't have to listen to me speaking if you don't want to, if you're sick of my voice, which is, you know, fair enough. I can understand that, but if you just want to go through the presentation file, it's going to be put up on Google Drive. As I said, I'm going to create accounts for you guys, and the idea is that the process that you'll do every day is log onto the computer and open up Google Drive straight away. So you'll have your own Gmail account and everything like that. And if I need to contact you, I'll contact you through Gmail. It's a separate Gmail account. And any documents, which is up here, any documents that I publish to you guys, like assignments or programming exercise or anything like that, I'll put up on Google Drive so you can access it wherever you are, whether it be in the classroom or at home or in the library on a line off or whatever. The whole idea, as I think I've mentioned, the whole idea is for me to give you the information wherever you are at any time. So if you get the inspiration at 3 o'clock in the morning to program, I don't want to be the person stopping you doing that. You can just log on, find out what the assignment is, and have a copy of it there and just start programming. So I don't want to be the thing that's holding you back. That's the idea about it. All right. Data. These computers at the moment are not in this current state, but it's still a good idea to get practice from day one. All the data that we're going to be using, you are responsible for it. The school is not going to, we're going to wash our hands, or, you know, whatever the phrase is. We're not going to take responsibility for your data. Unfortunately, it's something that, you know, we'd like to do, we want to do, but at the moment it's not possible because these computers are not entirely usable. There's SchoolsNet. I don't know if you're familiar with SchoolsNet computers from your old school or from last year for Year 12s. But SchoolsNet is not ideal for our situation, so we're going to wipe all of these computers and install our own version of the operating system on them that hopefully will work a lot better. But in the meantime, it means that you're responsible for your data. So if you need to bring in a USB drive, bring it in. If you don't have one, unfortunately, you might need to dig one up or buy one. They're only like $5 for a 4 gig one. 4 gigs is more than enough for this subject, more than enough. But you're also responsible for backups. Seeing as we're sort of using Google Drive for all the documents, Google Drive is a good option for you guys to use it because you can just upload your documents to there. Any programs we write, you can upload to that. Have that backed up so you can access it from home as well. So Google Drive is a really good option, but if you do prefer like a USB drive, I know a lot of people do, you can use those as well, but you guys are responsible. The example I've used in my other classes is I don't accept the excuse, I lost my backup, I lost my data. It's the new version, the 2013 or 2014 version of the dog ate my homework excuse. I don't accept it because with the amount of websites like Dropbox, Google Drive, and all this sort of stuff, you should have enough backups of your data. So if you come to me the day before the assignment's due, and it has happened in previous years, come to me before the assignment's due and say, I lost all my assignment, I can't hand it in, my first response is, where's your backup? If you don't have one, then there's nothing I can do about it. Okay, I can only mark what I see. So if that makes sense. If you have an issue with it, I'm happy to talk about that later, but that's my basic stance for all my classes, not just this one, all my classes. You need to have backups. And if you want help setting up a backup system, I'm happy to work with you as well, because it all depends on your situation and what you're comfortable with. Anyway, so that's your data. Semester goals. What we're doing this semester is you're going to learn how to program. And some people have already programmed. I know I talked about on Monday, a couple of people have learned a few different languages. We're going to learn the basics of programming. Okay, so we're going to learn Java and Python, but also, more importantly, we're going to look at logic, program logic, how to get from the start to the end of code. So that's looking at how to get inputs, how to process those inputs to do what you want it to do, and how to output it. Now that might mean breaking a really large problem into smaller chunks that do the same thing, input, processing, output, and a combination of all that sort of stuff, but it's going to be basically that. We're going to look at, so reflect and compare different programming languages. As I said, Java, Python, they're the two ones we're going to be looking at, and because they're quite different. So the reason why I'm doing that is to give you an appreciation of different programming languages, why they exist, and what their purpose are. So, well, I suppose that's the same thing. What the purpose of each different languages are, if I could speak English properly. That's the idea about it. In the past, I've just taught one language, which is great, but then the students at the end of the semester are good at Java. They might not necessarily be a good programmer, they might be a good Java programmer. And I want to get rid of the language and just make you guys good programmers, which means that if you get a job or give it a task to say, you need to work in this language, you can pick that up really easily. I worked with a guy, before becoming a teacher, I worked for a software development company, and one of the jobs I had, one of the guys, I think he was a C++ programmer, I think it was. And he wrote really good code in C++. Anyway, there was around the sort of the .com bust, the bubble bursting in 2000, he was put onto different projects, and he was told on a Friday that he was going to be working on this other product that he'd never touched before. And he said, that's fine. What language is it written in? And they said, it's Java, Java-based. So over the weekend, he learned Java. So in 24 hours, 48 hours, he learned Java. Now, he had like 5-10 years experience before he got to that point, but I want you to get to the point where you can pick up a new language and learn it really quickly, because then it's just syntax. You already know the logic, you just have to apply it to that language. That's my goal for you guys. And then the ultimately as well is to get ready for robotics next year and for intermediate program, which is the next sort of level of programming. It's called object-oriented programming, where it's sort of the next conceptual level. But I'll talk about that a bit more, probably, well, this time next year. But yeah, that's the next goal. All right. So as I talked about, sort of already covered this, I'm going to look at logic. We're going to be using flowcharts for that. There's a great product. I'll give you the URL later on that. It's called Raptor. You can write flowcharts in it and actually run the code. And it will process the inputs and it will output it, and you can test the logic of your code before you start writing any code. So it's really, really good. And we're going to be doing Java and Python. Also, I don't know Python all that well. I've learned a bit of it, but I don't know the whole thing. So I'm going to be learning it sort of as we go along. So there might be times when I don't know the answer to your problem, and we have to research it together. So just to warn you as well, I know Java quite well, Python not so much. All right, so the format of this unit is each topic. I'm going to give a lecture like this, and I'm going to record it, put it up on YouTube, and I'll show you the logic of it using flowcharts because they're very visual. I'll talk about them in a lot more detail later, not today, but they're very visual, so you can see how the logic works, and then I'll show you how you implement that logic in code. And as we go along, we're going to sort of build up a programming project. So you're going to see the logic, you're going to see the code, and then we're going to apply that logic and the code to a programming project that's going to last possibly the term, maybe going into next term as well. We'll see how long it goes. And I'll talk about that project in a minute. Anyway, so here are the topics, sort of general topics. These are a bit out of order. I'm going to have to update them because debugging is topic 12, and that should be a lot higher than that. I left it a bit too late. Anyway, these are not week by week. I might do 3 topics in 1 week and then spend a lot more time on the code and programming. But these are the sort of the sequence of topics we're going to be covering. So we're going to look at how to define a problem, which is using flowcharts, how to break it down. We're going to be looking at Java and Python, formatting code, variables, maths, Boolean expressions, which are relationship expressions, like is this number greater than this number, is it less than this number, those sorts of things. This is where I edit the video. Control structures, which are a decision basically. So if this number is greater than this, do this task. If it's less than this, do this task. That sort of thing. So that's where you branch out the code into different things. Arrays, kind of hard to talk about arrays without talking about variables first. So we'll talk about that later. But they're more complex variables basically, which is hard to explain if you don't know what a variable is. Modules, which is breaking it up into smaller parts, as I said, and development methodologies. We're going to be looking at, I want to do this because I haven't done this much in the past, but we're going to look at how teams work in real life situations, sort of in different ways, and we'll look at the benefits and the not so benefits of them. I've forgotten the word. So there's things like there's waterfall model, there's agile development, there's extreme programming. That's a thing. It's called extreme programming, and it's not doing it while abseiling down a mountain, although it does kind of give that idea. And there's a few other ones, but we're going to be looking at those. And my idea for that, this is probably going to be more closer to for term 2 than this term, but my idea for that is actually to model them. So we break the class up into like groups of 4, and you guys work in an agile, like all the same project, sorry, same exercise, but you guys here work as an agile development. You guys work as extreme programmers. You guys work as I've forgotten the other one, but like waterfall, and there's another one. So I might sort of break up, and then we can come back together after the lesson, and then talk about how it worked for that particular problem, and see which one's good and which one's bad for that situation. Other situations, they might be great. All right. Assessments, very important things, because they determine what mark you get at the end of the semester. I'm going to give you the unit outline, which for college is a very formal document. I'm going to give that to you later because this is still kind of up in the air. I've got to sort of make sure it's absolutely 100% correct, but I wanted to give you an idea of what's coming. Term 1, which actually finishes in week 9. It's kind of strange. Finishes in week 9. Term 2 starts in week 10, which is just before the holidays. So you have a week of term 2 before you go on holidays. It's kind of odd, but that's what happens. So before week 9, we're going to have an assignment and a test. Okay, and then starting in term 2, we're going to have another assignment, a reflection assignment, which is going to be about evaluating programming languages and things like that, and maybe the programming, the development methodologies, and then an exam. So just to give you an idea, the exam has to be done by, or the first 2, the assignment and the exam have to be done by week 9. The exam is easy. That's going to be in class. It's an hour or whatever. That's going to be there. The assignment's going to have to be due in week 9 or week 8, pretty much. The assignments usually go for 3 or 4 weeks. So let's say it's due week 8. It's and you've got it for 3 weeks, that is week, let's say 6, maybe going to week 5. We're in week 1 now. So that only gives us like 4 or 5 weeks to cover content before you get the assignment. So it's going to be a busy 4 or 5 weeks. Okay, there's going to be a lot of these lectures. We're recorded and it's going to be very busy. I'm not trying to scare you off. I'm just trying to give you an idea of what's coming over the next month. Because that's what we're talking about, a month and maybe another week before you get your assignment. Okay? I don't want to give you an assignment too early or too late and have like an assignment that's you only have it for 2 weeks, but it's a busy 2 weeks. I want to give you the time to be able to actually plan out a proper answer to the assignment. Okay? As I said, I don't want to scare you away. I'm just giving you an idea of what's coming up. Okay? It's all doable. This is what I've done, for the last, I don't know, however many years. But just wanted to give you an idea so you know what's coming. All right. VET competencies. I'll talk about VET a lot more later, but suffice to say, you do get VET competencies. VET competencies are different from a grade at the end of the semester. A grade is how well you did, A, B, C, D. You get a score as well. That's how well you did it. Competencies are, can you do it or not? Are you able to perform this task? These are the competencies that you can gain by doing this unit. You don't automatically get it. Some of the titles don't give a good indication about what is covered in those topics, in those competencies. Yeah, I can go into them more detail later. I do need to, because in case we get audited by the people that audit VET, they can come into the school and audit me and ask me questions about VET, and I can answer them. They can actually come in and question you guys and come in and say, what competencies are assessed in this unit? Now, you don't need to know them off the top of your head because, hey, I don't know them off the top of my head. That's why I've got them written down. But you can say, look, actually, I don't know, but Ryan did talk about them in week 1 and they're part of the presentation. I can find out. And that's all that's what they care about. But you just need to be able to answer some basic questions about VET to make sure that I'm doing my job in informing you and assessing you on VET. It's not all they care about. There's a lot more they care about. Anyway, so we'll talk about VET a lot more. They usually come up during assessment tasks, but, and at the end of the 2 years, and if you're really keen, for the Year 12s particularly, at the end of, you could get your Cert 2 in IT, which is the highest we can grant, is a Cert 2. You can actually get that done in a year if you really, really try. But generally over the 2 years, particularly if you're doing 2 streams of IT, programming and 3D or programming and networking, we can get you either to the line to get a Cert 2 or that. And Cert 2 is really good because you can finish Year 12 with your Year 12 certificate, an ATAR and a Cert 2, or a combination of those things.
Sorry.
Yeah, you're doing that? All right. Cool. All right. It's okay. I wasn't doing it to you. Sorry. I was making fun of him. All right. The good thing is that's not recorded, so that can be live. Anyway, sorry. Distraction. What are you talking about? VET competencies. So yeah, you can get Cert 2. Now, Cert 2 means that when you get a job, you can say, hey, look, I am competent in IT to a Cert 2 level, which is nationally recognised. So you can go anywhere in Australia with that competency, the certificate, and that's recognised. If you go to CRT, they give you sort of priority enrolment based on that competency, or based on that certificate. So just be aware, it's a really good thing to have, but we can talk about that in more detail later. All right, programming, the actual art and science or whatever of programming. We've got class for 3 hours and 45 minutes per week. Now, it's not actually 3 hours and 45 minutes per week because by the time you walk in, you log on, you say hello, you insult each other across the room and get on and open up the program and all this stuff. It cuts it down to, I'm rounding it off to about 3 hours a week. That is nowhere near enough to become a really good programmer. But honestly, it's not enough. 3 hours a week is not enough to be a really good programmer. If you want to become a good programmer, and I'm talking about sort of a C grade or above, possibly even above a C grade, you need to put in more time, okay? The software we use, which comes up in a later slide, the software we use is all free and downloadable, so you can download it at home. I'm happy to download it here, or you guys download it here and take it home yourself. That's all fine. I can help you set it up if you need to, particularly Python. That's a bit tricky the way I've got it, but we can easily set it up and you can do it at home. It's going to be installed on all these computers. These computers are available every single lunchtime. This room, if it's not open, will be open. All you have to do is ask your teacher to open it. They'll open it up for you. The library will be available for these programming, or Thursday afternoon, this room as well. Okay, I just wanted to tell you, or do it at home, whatever. 3 hours, 45 minutes is not enough time to be a good programmer. You might be able to pass a unit, but if you want to be a good programmer, it needs more time. And I know some people can't do a very good programming when there's lots of talking going on, when there's distractions. I need to shut the world out when I'm coding because I can't have any distractions, but we'll have to work around that. Yeah, that's about it on the programming stuff. Software, Raptor and Eclipse. They're the two pieces of software we're going to be using all term, maybe a few other websites. Is that good? Excellent. Thumbs up. Cool. Raptor and Eclipse are free. I think I've got the URL. Hey, there we go. URL's there. Eclipse, when you download it, that's got Java built in. It's all set up. You just have to unzip it, and it's all good. The Python plugin is a bit more tricky, but go to that website, PyDev, and on the right-hand side, I think there's an install button, or along the top there's install or whatever, and there's some steps on the right-hand side then I think to show you how to install it. And you have to do it inside Eclipse. You have to download and install the plugin in Eclipse, so it's a bit tricky. It's not that hard. It's just, it's different from downloading Eclipse and installing it. So yeah, they're the two pieces of software you're going to be using, and that's pretty much going to take us through all semester. All right, our units, registered unit, they're sort of subjects or units that you do outside class time. I think the sign up for that is tomorrow afternoon, or tomorrow lunchtime, sorry, down in the gym. Is that right? Yes? Cool. I'm glad someone was paying attention to that, and because I wasn't. So, but basically, the school, what we want to do is have more IT support around the school, and we thought it'd be great if you, for the people that were keen, if you wanted to get some experience helping teachers with their IT things, installing software, and just sort of general IT support, you can get points for that and recognition and all that sort of stuff. If you're interested in it, come along tomorrow lunchtime down in the gym, or you can come and see me. The idea is we're going to start it in about week 3. So week 1 now, in a couple of weeks, we'll start it up. And it's going to be based on, it might only be like an hour or 2 a week for if you sign up to it, and that's all you do. So you say, like, on line 2, I'm off, and on on Wednesday, line 2, I'm available. I'll walk around the school and ask teachers if they need help. So that sort of thing. Also, if particularly I'm looking for someone who's interested or knows anything about Macs, because I'm going to be managing this lab, the lab next door, and the photography lab, and I don't have the time to help all the teachers with all their support. So if you're interested in supporting particularly Macs, please let me know, and we can sign up on that. Anyway. I'm not signing you up. You're doubly on my list. All right, so how much time have I got left? This class finishes in 10 minutes. Cool. All right, so give you an idea about what's happening for the next 2 years. Okay? Don't want to rush you into anything, but I've got a plan for you for the next 2 years. This semester, Programming Fundamentals. Learn the basics or the fundamentals of programming. Surprisingly, that's what the subject's called. Looking at all the things in the lecture series I talked about. Next semester, we're going to be doing robotics. So you're going to be using Lego robotics, Lego NXT kits, which there are none up there. Okay, cool. Did anyone do Lego at their high school? Yep. Did you use NXTs or the RCXs or? In year 8. Did they look like this? Yeah. Cool. These are NXTs. So these are the Lego, they're called bricks. And I've named them all after Star Wars characters because, I named them, so Star Wars. But basically what you do is you write your code on the computer and then push it, deploy it to the bricks. And you've got a couple of, these are the sensor ports here. So you can plug in a compass sensor, a touch sensor, a sound sensor, a gyroscope, which tells you if it's falling down or falling up or which way is it falling, an accelerometer, which does a similar thing. There's a sonar, which tells you how far something is away from the robot. And there's motors, or they're called servos in robotics. We'll talk about that next semester, but you can get it based on how far something is away. You can get your robot to move towards it or move away from it. Particularly at the end of the semester 2, the idea is, could change, but the idea is that you'll build this to 2 of them to play soccer against another team of 2 robots. So that's what it is. This is the new one. This is called an EV3. I have no idea what EV3 stands for. I can only assume these are NXTs as in next, because these were the 2nd generation of Lego robotics. So these will be the next version. EV3, I don't know, something version 3. But anyway, these are faster, better, stronger. These actually run Linux, some flavour of Linux on it. So anyway, so that's what we're going to do. And then this time next year, as I said, we're going to look at intermediate programming, which is object-oriented programming, the next level up. You can actually do that in Java. Object-oriented programming does, well, Java is an object-oriented language, and so is Python for that matter. So this time next year, we might be doing Java again. These ones we program in C, a version of C. That's another programming language. So this time next year, we could be looking at Java again. What I'm doing for the Year 12s in that unit now, well, they find this out in about an hour. We're going to write an Android app, or they're going to write Android apps. The other option is we write iPhone, iPad apps, but that's a different language. That's Objective-C. I think that's really cool. I want to do Objective-C. iPhone, iPad is where I'm at. I want you guys this time next year to start writing iPhone, iPad apps. But we'll see what happens. If I get run over by a bus, you might be doing something else. And then the final unit, I've just started this last year. It's very cool, microcontrollers. Has anyone heard of Arduinos? One person? Excellent. Arduino is, surprisingly, a microcontroller. Now, microcontroller is a really cut-down version of a CPU with a few additions to it. This square chip in the middle, that's a CPU or a microcontroller. It's a really, really cut-down version. It's, can't remember, I think it's like an 8 megahertz, no, more than that, 16 megahertz processor, so it's it's slow compared to the computers around the room. But what you do with it is it's sort of the next, it's a lower level, more hardware level than robotics. These can be used for robotics things. So what the task was, or the assignment was last year, is to build a remote control car. So this is some student who forgot to pick it up at the end of the year. But there's a remote control car, but he put on top this Arduino board and added in a GPS unit. And so he can actually track, when he drives around, it tracks GPS coordinates I think he did it every 30 seconds. And then he uploaded that data, because it writes it to an SD card, upload it to Google Maps, and it shows on Google Maps where you drove the car. So that's where you're going to end up. So the way it sort of works is, this semester, it's a really broad subject. We're going to be looking at just programming in general. Next semester, we look at sort of converting our broad programming knowledge down to something that works just on these. So it pulls it right in. Next semester, we branch it back out to object-oriented programming, and then we pull it right down to program these things. Now, the code for this is really, really basic. These Arduino boards only have like maybe 500K of memory. Really tiny. Almost no RAM whatsoever. So they're really, really basic sort of stuff. This is another type of Arduino. Try not to break it. This one's basically the same as this one. It's just got more pins, and the pins is where you plug in the electronic components. So we have to learn a bit of electronics in there as well, which is cool. But this, it's called a shield, can sit on top of your Arduino board, and all this does, this whole board gives you Ethernet access and SD card access. So the whole thing's set up just for those two things. So it's really, really low level stuff, and you have to program it absolutely. It's not plug and play. You don't plug in an Ethernet cable and you've got the internet. Not that easy. You have to actually program the whole thing. It's really cool. Anyway, just wanted to give you an idea of what's coming up and where we're going. If you're interested in Arduino, by all means, they're only, like, the thing is, this one, they're about $12, maybe $15 on eBay. They're really, really dirt cheap. If you buy an official one, they're maybe $30, but you can buy them for like 10, 15 bucks on eBay. They're really, really good. And all the components can be like 5, 10 bucks as well. So it's really cool. Anyway, so that's what the idea is we're going to do. All right, this is the last slide. Okay, I know it's almost lunchtime, and I've talked for a long time. I don't like talking this much. I know you don't like listening to me this much. The whole unit's not going to be like this. But anyway, we're going to write a Fight Club game. This is the project that we're going to be working on as we learn our programming. We're going to learn how to basically, and we're going to sort of slowly build up. We're going to start with just some basic stuff like saying, "Welcome to Fight Club. Don't talk about Fight Club," that sort of thing. And then we're going to add in collecting information from the user, as in what's your name, how many fights have you won before, how many fights have you lost before, that sort of thing. I might change the theme. I don't know. It was just when I was writing this that Fight Club is what I think what Fight Club was on the TV or something like that, or whatever. And then we're going to add in other things like decisions. We're going to add in loops. We're going to add in different functions and things like that. So we're going to slowly build it up and then do other things. Possibly. We're in charge of where this game goes. So yeah, we'll see what happens. All right, that is it. I'm going to